Hello and welcome. I am Dr. Pauline Fu. In this video, I will present confidence interval and prediction interval for least square regression model. So remember, in least square regression model, we explored the relationship between two variables. One is explanatory variable x, the other is response variable y. We want to see if there is a linear relationship between x, y or not. In this lecture, we'll use confidence interval and prediction intervals for the least square regression model. And specifically, we'll construct confidence interval for a mean response, and we'll construct prediction intervals for an individual response. Both situations, we will produce a range of response variable between which value and which value, okay? Confidence interval for a mean response are intervals. So there are two numbers. One is lower bound, the other is upper bound. This range is about predicted value of y. Y is response variable at a given level of x. So if I give you a specific x, what will be the range of y? Okay. So that are used to measure the accuracy of the mean response for all individuals in population. On another hand, prediction intervals for our individual response are also intervals, lower bound, upper bound, constructed about predicted value of y that used to measure the accuracy of a single individual prediction value. Okay, so the first one, confidence interval, is about the mean, okay, mean response. The mean response. And the prediction interval is about individual. Okay, measure the accuracy of individual. Because the result we need the interval, so we need to calculate the lower bound and the upper bound. We will construct confidence interval for the mean response of y. And we are going to use, for example, 95% confidence interval for y hat. The mean response of y for a specific value of x is given. This is a specific value. Okay. Remember what is y hat? Y hat is the predicted y based on the model. Okay. Remember, how did you get your model? You need two numbers to get the model. One is intercept. The other is slope. Okay. Once you have those two numbers, you can write a model. Okay. So the lower bound is y hat minus t subscript half alpha. That is the critical value. SE, standard error of estimate. And X star is the given value of explanatory variable. And N is the sample size. Okay. The critical value T half alpha have degree of freedom N-2. And X bar is the average of X So that is the formula for confidence interval for the mean response of y. Now let's look at an example. Construct a confidence interval for a mean response. This example is for the drilling data. Okay, the data here in the last lecture. So it's based on this data. X is the depth. Y is the time to drill 5 feet. Okay. So the question asks you, construct 95% confidence interval about the predicted mean time to drill 5 feet for all drillings started at a depth of 110. This 110 is the X star, okay, a particular value that is given, okay. So this is our X star in the formula. We are asked to produce 95% confidence interval. So we are asked to calculate what is the lower bound, what is upper bound. That is the question. Okay, so let's analyze this question, the calculation here. We could calculate the critical value given 95% confidence interval. If you have 95% confidence interval, alpha equal to 1 minus confidence interval, 95%. So alpha is 5% or 0.05, that is alpha, okay? And we can calculate the critical value T half alpha. You can either use the table or use the Excel, okay? So let's do the Excel. I want to calculate the critical value, okay? So equal T dot INV. Oops. I have to make sure this cell is the number. So I'm going to format the cell. Make sure it is number. Maybe increase decimal places. So now I type in the formula equal T dot INV dot 2T. Probability 0.05. Degree of freedom is 10. Because this data we have n sample size equal to 12. 12 minus 2 is 10. Okay. So now we get the critical value. Okay, 2.2281. I'll just copy down this one here. So this value equal to 2.2281. So we know the critical value. Okay. And now we need to calculate SE, standard error of the estimate. Okay. And how do we calculate standard error of the estimate? We did that in the previous lecture. Here, there is a simple way to find the standard error of the estimate. You just go to the regression result. See here, this number is the standard error of estimate. Maybe I need to repeat myself. So what I'm going to do, I will start from a scratch to produce the summary output, okay? So I'm going to maybe delete everything here. Okay. So what I want to do, I want to find standard error of estimate using Excel. We already used formula by hand in the last lecture. Now I want to use Excel. So go to data, and then data analysis, regression, click OK button. Y from B1 to B13 is already here. Maybe I will delete, start everything from scratch, so you understand the process. So Y from B1 to B13, X from A1 to A13. As you can see, I include labels. So the output range, I will put the output maybe here, F3. No, this is not output. So Y range is here. Output is a D3, maybe I want here, F3. Okay, I don't need residue plot. Okay, so click OK button. See, this is the output. And in this output, where do you find standard error? This number here. I'll highlight. This, see, is the standard error. Okay, this is the standard error, SE. Okay, standard error, SE. I will just copy this one into the OneNote so that I may need annotation later on. Okay, so I'm going to increase. Okay, so anyway, this 0.5196, this is my standard error S subscript E. Okay, so in the formula, we know SE. Okay, we just found critical value T half alpha. So this guy is T half alpha. Okay, and we found SE from Excel. Now what is N? N is 12 sample size. Okay, next with X star. X star is the given value. See, this is X star 110. Okay, X star. And next, we need to know X bar. So we go to Excel to find X bar. X bar means, I will delete this one, the average of this number of all X, that is X bar. So equal average. Select all the X. So this is X bar, 126.25. Okay, so we know X bar, so I'm going to write down X bar is the average of all X, and the result is 126.25. Okay, so we know X bar. Okay, so we know every number in this formula. Okay. So we can calculate the lower bound. Lower bound. Okay. And similarly, we can calculate the upper bound. Okay. So that is the analogy for constructing confidence interval for mean response. Okay. So the specific calculation is here. Okay. Remember we did this SE from Excel. In last lecture, we did this SE by hand using formula. And we just calculated X bar. And also in last lecture, we did Xi minus X bar square. Then add them all. Okay, it is this number. Critical value T half alpha is this one. Okay, and then you just plug in related number into the formula. You get the lower bound, upper bound. Okay. So that is the confidence interval for our mean response. For our mean response. So what is your conclusion? So we are 95% confident that the mean time, because it is for the mean response, the mean time to drill 5 feet for all drillings started at a depth of 110 feet is between 6.45 and 7.15 minutes. So we produced an interval, 2 numbers between this number and this number, given specific x at 110. Okay. All right, that is the confidence intervals for mean response. Next, I will present prediction interval for an individual response. So if you have keyword prediction, it relates to individual response. If you have a keyword confidence interval, you have keyword mean. So confidence interval relates to the mean response, and prediction interval relates to individual response. And the formula very similar to the one we just did, except you have this extra one here. Other than that, those formulas are same except this part here. You need to add one here. Okay. So let's do this example. Construct 95% prediction interval about the predicted time to drill 5 feet for a single drilling started at the depth of 110. So this is X star. Okay, X star. So again, all the numbers exactly the same. Okay. So for example, SE, standard deviation, X bar is the same, and this one sigma Xi minus X bar is the same, critical value is the same. The only difference is here. You have one here. In the previous example, see, you do not have one, okay? So that is the formula difference between confidence interval and the prediction interval. Okay. Because the prediction interval has one, as you can imagine, will produce a larger range than confidence interval. If confidence interval is this size, prediction interval will produce this size. Okay. So if you plug in the numbers and you get the lower bound, upper bound. If you compare this lower bound with the one we did before, it's smaller than this one. Okay, and upper bound, if you compare this upper bound with this upper bound, this is bigger. That's why the prediction interval will produce a larger interval. Okay, confidence interval is smaller than prediction interval. Okay, the reason is the confidence interval is for the mean response. Prediction interval is for individual response. Okay. And the last slide, the conclusion. Conclusion, we are 95% confident that the time to drill 5 feet for a random drilling started at a depth of 110 feet is between 5.59 and 8.01 minutes. And this graph shows you the confidence interval for mean versus prediction interval for individual. Okay, so if you are given a specific x, for example, x equal to 110, as in our examples, okay, and you will produce confidence interval. So this part represents confidence interval, okay, from here to here. And if you compare the prediction interval, this is the prediction interval, has a larger interval than confidence interval, because prediction interval is targeting individual. Confidence interval is for the mean. Okay. In other words, you actually get more accurate result for the mean. When we use interval, of course, we hope the smaller interval, the more information. Okay, for example, if I ask you, you guess my age, if say, okay, my age is between 40 years old and 60, that is a larger interval. Or you can say, okay, my age is between 50 and 55, it's a smaller interval. Okay, it's more targeting my age. Okay. All right, so in summary, what I did in this video, I construct confidence interval for mean response. I also construct a prediction interval for individual response. It is just use the formula, okay? And you need maybe Excel to get some necessary data. That's all for this lecture. I hope you learned something from this lecture series. Thank you so much for all your support, your understanding, your participation. I hope you all the best.